Chapter 1, Section 6b. We're continuing solving equations with radicals. Every one of the radicals we did on Wednesday was all square roots. So this is the exact same thing we've been doing, but now it's going to be different roots. Third root, fourth root, something like that. So a couple things to keep in mind, and there's different ways you can solve these problems. If you guys math weigh them, it might be a different way. I'm going to show you the easiest way to do it. Mathway doesn't always do it the easiest way, so you might be confused at how they do it. But if it's a root, anything other than a square, raise it to the same power as the index. What is the index? All right, you guys read that and you're like, oh, okay, cool. Well, what's the index? It's the root. So if this is the third root, how do you get rid of the third root? You cube, right? If it's the fourth root, how do you get rid of the fourth root? You fourth it, you for it, okay? If it's the fifth root, what do? Raise both sides to the fifth power, okay? Just like a square root, to undo a square root, the index on a square root, guys, is a little 2. You just don't write it. So how do you get rid of that? You square it. Those are inverses of each other. The second thing says if the expression is raised to a fractional exponent, to raise it to the reciprocal. Meaning, if I have the half root, what's another way I can write a half root? Square root, yep. What is the third root? The cube root. What is the fourth root? The fourth root, what was 1/4? The fourth root. So when they tell you to raise to the reciprocal, what's the reciprocal of 1/2? 2. What's the reciprocal of 1/3? 3. So think about that, guys. If you have the 1/3 power, that's the third root. How would you undo the third root? You'd raise it to the third power. There's some, though, that I don't think the reciprocal is the easiest thing. I think you should do it in 2 steps. I'll show you. I think you should raise to the denominator, which is the index, and then perform the operation. I'll show you what I mean in a second. So let's look at these first few examples. All right, this is the exact same thing we did last week, except now we have cube roots instead of square roots. I have 2 radicals, yes? In order to cube or undo, I need to have one radical on one side and one where? On the other. So let's go ahead and move this one over here. Everybody okay with that? So we have the cube root of 4x squared minus 4x plus 1 equals positive cube root of x. I have one radical on one side, one on the other. How do I undo the cube root? We're going to cube it. What you do to one side, you do to the other. So when you cube a cube root, it cancels. 4x squared minus 4x plus 1 equals, when you cube a cube root, you have just x. Now this is a quadratic that you guys have done for weeks now, months in this class. How do I solve this? What do I do with that x? I'm going to minus x from both sides. So 4x squared minus 5x plus 1. At this point, guys, you guys know several ways to solve quadratics. Completing the square, factoring, quadratic formula. What is the fastest thing to do? Factor. Always try to factor. So let's talk about this. 4 times 1. What are the factors of 4? That multiply to give me 4. It adds to give me negative 5. Negative 4 and negative 1. Okay. So I'm going to say 4x squared minus 4x minus 1x plus 1 equals 0. You could do it the shortcut way too if you want. So group the first 2 and group the second 2. What can I take out of 4x squared minus 4x? A 4x, good. And you're left with x minus 1. What can I take out of negative 1x and a positive 1? Negative 1, I'm left with x minus 1. Good. So my 2 parentheses are x minus 1 and 4x minus 1 equals 0. So what are my 2 answers? X equals 1 and x equals 1/4. There you go. If you want to check, you can. It's not necessarily, you don't have to because you're taking a cube root, so you can have negatives underneath. It's fine. All right, look at the next one. This is the exact same problem that we just did, guys. It's just written a little differently. When you see something raised to the 1/3 power, what root is that? The cube root. So if you want to rewrite this as the cube root of the first thing minus the cube root of the second, that's fine. You can also look at it and say, I have one thing on one side, I need to move this one to the other. So I have the cube root of 3x plus 7 equals the cube root of 4x plus 2. You could have left it as to the 1/3 power and then raised to the reciprocal. So what would you do to both sides? If it was the 1/3 power and you raised it to the reciprocal, what's the reciprocal of 1/3? 3/1. You're going to cube it anyways. So to solve this, we're going to cube both sides. This cancels, this cancels. We have 3x plus 7 equals 4x plus 2. How many answers am I going to have here? One. Good. Move x's to one side, guys. Numbers to the other. It doesn't matter which way. I always like to move x's to the left. You don't have to. So I have negative x equals negative 5. So what's x equal? Perfect. And when you get x equals a number, hang on, Luke. What can you do? Always, always, always you can check if you want to. Yes, sir. Wait, hold on. All right, look at the next one. What root is this? The 4th root. Okay, so big deal. I have one root on one side. It's isolated. There's nothing else happening to it. So how do I get rid of it? You're going to raise the left-hand side to what power? The 4th root. What you do to one side, guys, you do where? To the other. What happens when you raise something to the 4th power and it's the 4th root? It cancels. X squared plus 6x equals what? 16. 2 to the 4th power, not 8, guys. Now, at this point, you could complete the square. Somebody last period said, oh, I like to complete the square. Okay, fine. I'm going to go ahead and move everything over and try to do what? Try to factor. 6x minus 16 equals 0. If you want to use the quadratic, you can. It just takes longer. Are there factors of negative 16 that multiply to give me negative 16 but add to give me 6? Yep. X plus 8. X minus 2. So what are my two answers? Negative 8 and positive 2. Perfect. Good, good, good. All right, what do I do here? What is this question really saying? The 4th root, right? If you want to go ahead and rewrite this as the 4th root, you can. I'm not going to. I'm going to use the fact that I have a fractional exponent, and I'm just going to raise both sides to the denominator. What is the denominator of the fractional exponent? 4th. So if I multiply or raise this to the 4/1 power, what I do to one side, I do where? To the other. What happens when I multiply a power to a power here? What's 1/4 times 4/1? 1. It cancels. All right, we're doing the same thing as if this were the 4th root. You raise to the 4th power. Just want you to see that those things are the same. So 3x squared. Oh, wonderful. All right, so I have 3x squared, right? Plus 52x equals what? 256, okay? This is the hardest problem on today's notes. Not because Algebra 2-wise it's hard, it's because you have to find factors of a big number. All right, we're going to move everything over, and we're going to factor 3x squared plus 52x minus 256 equals 0. Please don't ask me, are we going to have something as big on the test? You might. So know how to do it. There's no GCF. This isn't a perfect square trinomial or anything. So what do? Multiply A times C. Factors of, what is 256 negative times 3? Negative 768, okay? Factors of negative 768. They're going to multiply to give me negative 768, but add to give me 52. Okay, then you have to divide every term by 3. 52 divided by 3 is not great. Positive 64 and negative 12. Do the grouping method, do my little shortcut method. But I'm going to write x plus 64, and I'm going to say x minus 12. If I do my little shortcut method, what do I have to divide both terms by? 3, okay. 64 does not divide pretty by 3, so 3x plus 64. Negative 12 divides by 3, nice and pretty, to what? Okay, so what are my two answers? X equals negative 64 over 3 and 4. There you go. Hardest thing today, and that's just because the number's big. All right, let's look at the last two. And then I have an extra one that I ran into on WebAssign. I just want to make sure you guys see. Okay. What do we notice about this problem? What do you notice? Okay, one has 2/5, one has 1/5, right? When I see 5 as my denominator, what root am I thinking? 5th root, okay. So the easiest thing to do, the easiest way to solve this, excuse me, is to raise each side to the denominator power, the index, okay? So I'm going to raise this side to 5/1, and what you do to one side, you do where? To the other. It's x minus 3 squared, whoops, equals 4x. Everybody with me? Okay. So what did you tell me? This is x minus 3 times what? X minus 3 equals 4x. We can all do this. X squared minus 6x plus 9 equals 4x. Subtract the 4x from both sides. So x squared minus what? 10x plus 9 equals 0. So what's x equal? So x minus 9 minus 1, right? So x equals 9 and x equals 1. Okay. All of you are raising both sides to what power? Perfect. I totally agree with that. So I'm going to raise this side to the 4/1 and this side to the 4/1. I agree. So on the right-hand side, what is this? X squared. Totally agree with you. How many of you distributed right here and got x cubed? If you multiply 3/4 times 4/1, you get 3. But guys, what happens here? No, 3 to the 4th power. What is the difference between this and this? One is in parentheses and one what? Is not. This is saying this whole thing is raised to the 1/5 power, so you don't distribute. This is saying the x is to the third. You have to distribute. That's where you guys made a mistake. So on a test, if you did that, you would have gotten a few points off. Hold on. You have to remember our exponent rules from like the 3rd day of school. Bailey. Yeah, I mean, if you put the that doesn't matter. That's just telling yourself. That means when I put this parenthesis on, that means this 4/1 goes to everything in the parenthesis. So when you simplify this, guys, what is 3 to the 4th power? 81. Then I have x cubed equals x squared. Now, here's a fatal mistake that a lot of you are still making. Some of you go like this. And then you cross this out like that. When you do that and you come up with 81x equals 1 and then you solve and you tell me x equals 1/81, you only found how many answers? 1. How many answers are in this problem? 3. You just cancel out wherever you guys feel like. If you have variables that's the same variable but with different exponents, like x to the 3rd, and x squared, move everything to one side and do what? Factor. 81x cubed minus x squared equals 0. What do they have in common? X squared. You guys most of you got that x squared part. So 81x minus 1 equals 0. So x squared equals 0. 81x minus 1 equals 0. So you take the square root of both sides and you get x equals 0, right? Plus or minus. Is there such thing as plus or minus 0? No, 0 doesn't have a positive or negative, but what this is telling you is you have 0 2 times. It's called multiplicity. We'll talk about that later on. That's one of those rare occasions that when you take the square root of a number, you get the same answer. It's not positive 2 and negative 2 or positive 1, negative 1. And then over here, you get x equals 1 over 81. Tricky little problem. All right, look at the last one. Oh, I forgot to write it down. Hold on. It's not the exact problem from all of yours, obviously. But this is on everyone's web assign. And I had some people email me last night that were working ahead. And they only got one of the answers. And I want to show you something that's very important. All right, the one that I just had written will only have one answer. I want you guys to see this. So yours will only have one. Okay, so if you guys were to mathway this, which is what people were doing yesterday, and they were like, I keep putting this in WebAssign, I'm only getting one, I'm getting one answer, but mathway is getting two. The reason why, what do I tell you guys to look at? The index is what number? The denominator or the numerator? The denominator. So if you are going to take the square root of a number, what do you have to put in front of your answer? Plus or minus, okay? So like the one that Fabi just gave me, hers was 2 over 3. So it was a cube root, you don't have to worry about it. But in a case like this, guys, if you just, don't write this down. If you just raise this to the 2/3 power, and you raise this one to the 2/3 power, which is raising to the reciprocal, whatever, obviously this will cancel, and then you guys would evaluate this, and you'll get one answer, because you're not really thinking. What the best thing to do, and that's why I showed you this from the beginning, is anytime you have a fractional exponent, raise each side to the denominator first. So when I am going to solve this and I raise to the denominator, what am I doing to both sides? Squaring it, right? I'm going to put it, the denominator is the one on the bottom. So 2 over 1. When I multiply right here, what happens when I multiply 3 over 2 times 2 over 1? The 2's cancel, so you have x minus 3, what? Cubed equals 8, what? 8 squared is 64. Okay, I'm going to do 2 different problems to show you the difference. How do I undo this now? Cube root, right? Okay, so x minus 3 equals, what's the cube root of 64? What number times itself 3 times gives me 64? I heard 8, 6, and 4. Which one is it? 4, okay? So what do you do to both sides now? X equals what? 7, okay, fine. Now I want to do Fabi's. What was yours?
X plus 7 to the 2/3 equals 9.
Did we take the square root?
No.
Okay. That's what I want you guys in your minds. Always, always, always raise to the denominator, then solve. Then you won't have to worry about, wait, when do we put plus or minus? When we take what? The square root. Did we take the square root there? No, we took the what? Cube root, okay? You don't put plus or minus for cube root, only for the even ones. So let's do this problem. Same exact thing. I'm going to raise to the denominator. So I'm going to raise both sides to what power? The 3 over 1. So 2/3 times 3 over 1 gives me x plus 7, what? Squared equals, what's 9 to the 3rd power? 729, okay. Huh? Hold on 1 second. Now, 2 things you could do at this point. 2 things we can do. I can write out x plus 7 how many times? Twice. Move 729 over and factor, yeah? What's another thing that we learned at this point that we could do? Take the what? Square root of both sides, yes? So when you square a square root, x plus 7 equals, what goes in front of your answer, guys? Plus or minus. Those little things we cannot forget. What is the square root of 729? 27. Now, when we go to solve this, what do I do to both sides? Subtract 7. Now, some of you will leave this like this and tell me, but I answered it. Is that an answer? No, that's not an answer. Do you see any variables or anything that you can't combine? Do you see any square roots that you can't combine? You guys have two very simple problems right here. You have negative 7 plus 27, and you have negative 7 minus 27. So what are your two answers? 20 and negative what? There you go. Please, guys, when you take the square root, some of you, if you just from the beginning here, just do the reciprocal, you're going to miss the plus or minus. So always just raise each side to the denominator and then worry about solving. If you take the square root, what goes in front of your answer? Guys, if you take the square root, what goes in front of your answer? Plus or minus. Okay.